Welcome to Cobotalks, a monthly seminar series. Second Wednesday every month since 14th October 2020. 20 plus speakers presented on Cobotics. Our collaborating partners IHFC, BIRD, Cognitive Science Program, a Department of Humanities and Social Sciences. IHF Foundation for Cobotics, Technology Innovation Hub of IIT Delhi, a national mission on interdisciplinary cyber-physical systems by DST, Department of Science and Technology, Government of India in March 2020. A Section 8 company, IHF Foundation for Cobotics (IHFC), was incorporated on June 13, 2020. About IHFC. Advances in sensing, computation, and autonomy are enabling robots and autonomous systems to enter real-world domains such as manufacturing, defense, medical, agriculture, etc., where machines must work alongside and interact with humans. We are entering an era of manned and unmanned teaming where humans and robotic systems must work together towards common goals. The four verticals of IHFC: medical, agriculture, industry, and defense. Our goals: human robot collaboration for enhancing human capability and reducing risk and improving productivity. Our objectives: research on novel technology areas of robotics and automation science, development of products for benefit of society, inculcation of startups, and promoting entrepreneurship in India. Our CQ: concept, collaborate, commercialize. From research to product. The grand projects of IHFC: medical simulator, human-robot interaction control, rehabilitation robotics, drone applications, healthcare robotics, human-robot interaction intelligence, intelligent sensing and secure communication, and Industry 4.0. BIRD, a center of excellence at IIT Delhi. About BIRD: biologically inspired robots and drones. The Center of Excellence on BIRD, biologically inspired robots and drones at IIT Delhi is an evolution from its humble research activities, which began a few decades ago by its faculty drawn from the Department of Mechanical, Electrical, and Computer Science Engineering. BIRD has 10 plus projects, industrial and academic, 27 plus members including faculty, students and technical staff across various departments of IIT Delhi, 150 plus publication in international and national conference and journals, 9 years of experience. Cognitive Science Program, a Department of Humanities and Social Sciences at IIT Delhi. Cognitive Science Group at IIT Delhi is to create a knowledge pool that can address relevant problems under the ambit of human cognition both for India and the world at large. It helps students acquire a strong background in theoretical frameworks and empirical approaches of one or more areas of cognitive science. Cognitive science is an emerging new field of study that endeavors to study the mind from multiple perspectives and disciplines by combining ideas, principles, and methods from psychology, linguistics, philosophy, computer science, and neuroscience. This knowledge is applied for developing a better understanding of how our minds, brains work while creating better products, tools, services, and policies. Cobotalks, leading the way in the human robot collaboration space. IHFC.
Can we have the IHFC video, please?
Ashish, check with the audio.
When we talk about ecosystem,
Is it audible right now?
Yes.
Yes, it is audible.
Yes, sir,
Thank
it
you.
is.
Cobotics means collaborative robotics, where human beings and robot work together.
We work on technologies of the future. We look at ways in which these technologies will actually get deployed.
we are trying to build an ecosystem here. When we talk about ecosystem, it starts from the kind of research capabilities that we are able to build. How is that we are able to instill the sense of commercialization in all those activities? When we talk about research, it's not only papers or publications.
So we have chosen four major thrust areas, you may call it. One is called the medical robotics. The second is the defense robotics. Third is the agriculture robotics. And fourth is the Industry 4.0 or Industry 5.0.
Mission of IHFC and the mission of IIT Delhi, there's a lot of synergy. And so we are treating IHFC as an extension of the things that we anyway want to do. The first goal of success would be creating an impact in society through some value add in terms of technologies and ideas.
I would definitely want IHFC to make an impact, an impact wherein we see indigenous products being developed, wherein we see our ecosystem coming together to see that we as an entity, we as a country, we as an ecosystem are able to build products on our own. So we should have export-oriented products being developed with whatever research capabilities we have, and that is what we want to do as a part of IHFC.
Can we please continue the talk? Yeah, I've done playing the videos.
Great. Okay, so hi everybody. Has everybody joined in? Have we let everybody in from the lobby, waiting lobby? That's completed. Guys, can you hear me?
Yes, Pia, we can hear
Yes,
you.
yes.
Okay, great. Okay, so let's officially start. Thank you for this video stream. And let me actually start today. I'm really, really happy because we are joined here by Prathvi, who actually is one of our latest startups to have joined our family, the IHFC family. And it is very encouraging to see such young people. He and Akshay are the two people who spearhead Pixuate, and they're going to be talking today to a lot about what they do and how AI is enabling everything. But to give them a little bit of an introduction and what they do and how they go about it, and welcome them very warmly, I would request, is Rohit Batra online?
Yes, ma'am, I'm online.
Okay, great. So Rohit, would you like to take this opportunity to introduce a little bit about Pixuate? And because we are here with Prathvi, and he's of course focused on image processing and computer vision, and he's developed over 30 enterprise applications. But I'm sure there's more to him, and Pixuate has so much to offer. So why don't you let us know as to what makes Pixuate stand apart and how brilliant they are?
Pia, you mentioned it all. You've hardly left anything for me to speak. But nevertheless, thank you so much, everyone, for this 44th edition of Cobotalks. So on behalf of IHFC, I welcome Pixuate, one of our success stories. They are predominantly working in the field of video analytics. I will not mention more about it, but I leave it to Prithvi and Akshita to take it on from here. Thank you so much for being part of Cobotalks today. Over to you, ma'am.
Thanks, Rohit. Thank you so much. So we are joined here by Akshita and Prathvi both. And it is such a pleasure to have you both here with us and to inspire young startups who are looking at being the future unicorns of tomorrow, just like you. So over to you, Prathvi and Akshita. Take it over. And I think we will have a question and answer session at the end. So guys, hold on to your questions till the presentation is over. Thank you so much. Prathvi, over to you.
Yeah, thank you, Pia, and thank you, Rohit, for the kind introduction. And yeah, thanks for the opportunity that I would like to take upon this opportunity to share a few things about the journey that we have and the project kind of work that we do, and also the key that we are talking about, that is the future of AI agents, right? So that's the this thing. So let me just share my screen, and then yeah, so everyone can see my screen.
Yes.
Yes. All right. So let me kind of brief about what we do. So we are a company working in this space, video analytics space, for like 10 plus years, starting with image processing, which started with the CV applications kind of a thing, and then moving on to the videos. So from where we started our product journey, which is like 7 plus years now. And so in this, we have done various use cases from face recognitions, from number plate recognitions. We do vehicle count and classification. We work extensively on the highways, where we do violation detection. We do some things like a wrong side detection. We do speed detection. We have patents on thermal based object tracking. So the lot been happening on the journey of last 7 years. And so the key that right now I want to share with everyone in the ecosystem also was this on the part where it is of AI agents, right? So we've all been updated with the changes that is happening around the LLMs and how it is disrupting the world. And my interest, or our team also with respect to where we started exploring this, was when we had few of the key things that we thought we can automate internally, and that's how we started getting introduced to LLMs and the models, and then the potential of that and all of that. So on the way, with the more capability coming into that, We also saw that how it has a potential to disrupt our video analytics space also. And at the end, I'll also brief on how it connects back to what we are doing also. But these are the some of the quotes that are shared by key tech leaders across the world, right? So none of them here needs an introduction. And so you will see this AI agents being more widely and extensively used in probably next 2 to 3 years. You will have a different kind of a future where the interaction would with the machine and the softwares and the systems would change drastically. So this is where the what so let's start with what is an AI agent, right? So essentially it's an autonomous software which takes a lot of context into the picture. It has also capabilities of or different LLMs that are part of it. There is machine learning models that are part of it. There are NLP that is part of it. So all of this are say if we separate it out, I'll also down the line try to separate things on what is agent versus other tools, and so we'll go into that. So like I said, the future of AI agents will be a lot more personalized softwares, lot more different experience into the world of AI. So let's understand this, that if the AI agents are new, right? So are they new? So if we look at RPA, robotic process automation, so you see some kind of automation happening there, and you see also something that is happening in the background continuously. It opens a software, it does a operation on the software, fills in the fields, reads a CSV or Excel, and that's an RPA to us. And you can say the automation anywheres and UI path. So there are different softwares which does that. So this was, I think, first level one of automations that started into the RPA space, and we have also at some point worked on it where we had to identify some images or things like that. So being well versed on this side. So now what differentiates it? The RPA does not have so let's go into that slide. So like so I've just tried to put across the comparison tables here where we have RPA, we have AI tools or bots, and then say AI agent. So if we look at an RPA, we have more rigid rules, like it has to open the software, and then if a software update is coming and the UI doesn't look like what it looked in the previous version, the flow will break. Or and then some of them started making small adoption to that and then said, okay, it works with this version also, this version also. So but it is still rigid, right? So it again requires if humanly you did this operation in 10 minutes, RPA also used to take same amount of time. Only thing that you could do is that you could spin up more instances, more systems, and parallelly work on this without having to add a human cost to this, right? So some part of automation coming into the picture, but still a lot of rigidity in terms of what the input and outputs to be precise, right? And next, coming to the AI tools, right? So if we take examples where we have a certain task related to a domain. So we started getting into uh, the Google Translate kind of a thing. So the tools which used AI and changed the give a output to a specific thing existed long ago. So the capability started increasing. We started taking a natural conversation and making a notes. Your Fireflies is one of the example. So, and even if you take the chatbots and all, right? So they are all trained in certain domain and then expects certain set of inputs. Beyond the input, beyond that, they generally kind of or beyond that limited set of inputs, they don't respond you with the right solution, or probably hands it over to the human for the conversation in case of a chatbot, things like that. So it is still having AI capability, but I will cover the key differentiator, at least from my experience, has been with respect to the AI agent versus a bot. But in terms of capabilities, I don't see a lot of difference between them. Both of them can be of equal capability wise from the AI point of view or the accuracy point of view and all of that. But coming to the key difference, right? So or what is that probably makes a AI agent agentic, or maybe how do we call this? So here, so with respect to AI tools, so we can think or bots, we can think of like a specific tools which are designated to do a specific task, although it can handle unstructured data. But when it comes to AI agent, one key thing that would be there is that it would still it takes again input from both structured, unstructured data, real-time data, web search. So there should be some input to this. And in my experience, it has to be automatic. So if you bring in a human intervention into this, that the input is now directly connected to the database, but somebody is entering it manually, probably it falls into the AI bot, probably not a agent. Although it requires some human input to be down the line, which I'll cover that. But essentially, lot of data should be available to it in the form of API, or in the form of a database that it is connecting to, or and a model, right? So these are the things that is like a input to the AI agent, and output from it. So output from it can again be a variety of it. So one thing that happens is like so if you think of it now, if you take a note taker example, you have a note taker converting this into text. But say, let's say we were having a conversation, and the manager said that in this you'll have to make a PPT which is for this customer doing this. So then if that translation, the Fireflies itself now starts making a PPT on that. So that means it is somewhere entering the domain of AI agent, where it autonomously joined the call, and there was unstructured input to that, and now it started working on that using a presentation, or it started making a presentation on that. So somewhere it is entering that domain, right? So this is how in a sense that agent is more like a trained domain expert human, available to do this task anytime, is a picture that we can paint in the mind. So that's the initial this thing on the AI agent. And then coming to the output part of it, it can be analysis, it can be predictions. So say if it is connecting to a weather API and ABC, then it predicts that this may happen, there may be a demand for cabs, and then it initiates an action, or there may be a demand for something. So it takes in the certain weather information and says that okay, this now the weather is more favorable for the tourists for travel and something, and then again spins up a secondary action on that. So it's more of that. So it takes in this real-time data, or a live data in the form of APIs, and then it starts a communication. Now, another thing that possibly differentiates a agent is also a two-way communication, that or a feedback that can come in between input and output. So for example, if I have to book a flight, and then there are two tickets available, right? And so one is probably taking 1 hour longer and 5,000 rupees less, and one is 1 hour I mean shorter duration, and then 5,000 more. So now at this point, probably if it wants to know my preference, and do you prefer to go 1 hour delayed, or the travel duration will be more versus you'll pay more. So probably this is where the personalization comes into picture, where that agent will start understanding what is the preference of this customer. And this is the point at which it changes from a bot to a agent. It's like your travel agent. He or she knows the preference that you have made previously, and then next time probably you will not be asked the same question. Then it knows for this cost range or for this much variation, there is a preference set. So this is where I hope I'm trying to give examples on this. I hope the things are clear. And anyways, I'll be available on the uh, Q&As. I'll be able to address. So now coming to the point of your agentic, again, one more example on this to cover the use case in a little bit better this thing. Say, let's say we have a content creation and publishing this thing. So let's say you want to post an article. So now if a agent is now mimicking a SEO expert, and so it starts with, say, like data collection. So this is where some bit of URLs or list of URLs, again, this also can be achieved by a Google search or a API based search or something like that, where I want to know, I take 10 or 20 top results from Google which is pertaining to this domain. So let's say I want to make an article on GNSS tolling. So I will probably give a Google search on this, and I mean via API, and that top 20 results is now considered as a URL list, right? So from here, it say goes to I've put a website called fireprowl.dev. Again, disclaimer, not anything to do with the promotion of it, but so basically the capability there is it takes the URL and then generates a LLM friendly data. Basically, it generates a markdown format of that data, and which is now can be given to an open API. Sorry, OpenAI API. So which is like a again a LLM that you'll have an alternative to that also. So now it goes into this prompt. So you also have some kind of a prompt engineering coming into picture, because what you want to convey in your blogs, because say, let's say I am working on products that are related to that, and I am an OEM of this product. So I have to give some kind of a context into how this data that is fetched from all these 20 URLs, how it is relevant to me, or what is that I want to generate the content, the article for, right? So that goes into the prompt engineering domain. So where we start understanding what kind of data is there, and then what should be your prompt to generate an article that is required for your website, where you want to publish that, right? So this goes into that part. So then again, you have some kind of a request parsing and all of that coming. So from data collection to the OpenAI, then going to the content generation. So with this data generated, we come up with a blog post that to be published, a title to for that blog, and the image generation prompt, right? So we have to add some image content also to this. So we use this existing data and then generate these three things. So post that, you have grammar check. You can also check for plagiarism. You have a SEO optimizer. So these are like more advanced part of it, but not required if you go for the first bit of it. So from there, it's directly a publication. So you have title and post and image. You can make a REST API call to your own website, which can be like a WordPress, or you have your own custom website. So you make a direct post request to that. So now what happens is it took this 20 articles, 20 trending articles again. It understood what is that you want to write using these articles, and then it generated these three things for it, went into grammar check, SEO optimization, and then published the article. So this whole thing will be repeatedly running. Also, this can generally look at your competitor websites, and that's how you would train an in-house SEO agent, also SEO person also, so that you go to the competitor website, see what keywords and all of that. And same thing can be mimicked by agent. So that's where again the picture of agent mimics more of a person in that domain, expert of that, and specialized in doing a specific task. So that's probably more and more specific definition of it. And so that's where we are. And I think till here I've covered all the things on the on this part. And coming to the specifically what we are doing with the AI agents again, and how we also have taken this journey so far. So that's what something that I wanted to take on this. So basically, see, 2018 to 22, the journey that we started from there was more of, detecting objects, where we trained detection models with, again, industry data, a lot of open data and things like that. So where we started training on specific use cases, right? And then model optimization. So all of this was part of that journey. Then slowly we went into the movement tracking, like we started tracking the objects, and then the speed, and then the direction. So all that is the second part of the journey, where we started working on building the algorithms on that. Then third is where we went into the behavior part of it. Now we have a object detected. Now we have a direction of it. Then if the direction is like zigzag, so then probably there is a rash driving involved here. So we went into the behavior part of it later, again 2024 kind of, where we started detecting this fall detection, rash driving, throwing object, so things like that. So use cases started getting added, right? And now coming to the the LLMs part, right? So this is where it shifted. Like, so at this point we thought, okay, we have covered a lot of things that is there, and suddenly we see this LLM coming up, and the thought process had to change, and we knew how big this opportunity was for the company. And so that's where the concept of video GPT is there, where which I can briefly explain as of now. On the anomaly detection part is where we are introducing with this capability. Say all the current traditional video analytics use cases that we see across, all are rule based. So what do I mean by that is that we have to set a zone, we have to set a line, and we say that, okay, when you cross this, do this, or when a person or object is detected in this zone, this is an alert, or this is or somebody is wearing ABC kind of a clothing, then it is a alert. Or say, let's say I'll give you an example of a security use case that we do. Say like an ATM, where you two people enter. It's a trigger to the command center, where somebody enters with a helmet, it's a trigger. Somebody sits down in the ATM, it's a trigger. Somebody lying down in an ATM, again, it's a trigger. So all of these are rules that are set in the system to trigger when ABC thing is happening. Okay, so but if we take it based on our newer this thing, where we are doing it as an anomaly detection, all that I tell the system is that somebody entering the ATM, withdrawing the cash, and going out, this is a normal behavior. So anything other than that, this is an anomaly. So if you think of it, you generally will tell this the same thing to the security guard, that somebody has to come in, just withdraw the cash and go out, right? So anything other than that is an anomaly, which is where a security guard is standing out and making sure this is happening. So so this is how a system changes from a non-rule to rule-based to a non-rule based, and this is where our journey is going to be. And this is where we are working on introducing this engine into our existing applications, and to make them at least 10x more powerful. It should be able to handle a lot more use cases without having to retrain, reconfigure. So these are the things that so we will be able to achieve, and possibly predict the next incident. So once you detect an anomaly and what is going to happen, then the next incidents can be easily predicted by the system, and action can be taken. So again, non-rule based. So that's the sorry. Should I continue? There is some disturbance in the mic?
No, sir.
Okay.
Please continue, sir.
Yeah. All right. So coming to the the workflow part of it, right? So what happens with this system is, they now say, let's say you have a park facing camera and then you have a video stream. We take out the raw data from it, frame extraction, image resizing, token optimization. So then it enters the multimodal LLM model, which is where a vision encoder takes it and converts this image into text. So all of this part. But if we have to stick to the output of it, right? So if you see, if this is the input given, it says that 3 individuals in outdoor setting, possibly a park, one person appears to be elderly. So all this is a description that it generates on an image that it sees. And now imagine that system setup in a view, and this image is getting this kind of a description is getting generated every frame, or every second, or every 10 second, or every 5 second. So this is how a system learns. In case of a our video GPT case, the system learns over a period of time, understands what's a normal, what's not a normal behavior. Say it's a place where everybody sits, it's a park, then possibly sitting down is not an alert, or not an anomaly there. So but over a period of time, it builds up this data, and you will see the system working flawlessly after it has seen a week of data, 1 month of data, and then it knows that, okay, then again the prompt part comes into picture. It takes in the context, what camera, what view it is seeing. It takes in the time of the day. It takes in the time of the month, what time it is it end of the week, that context comes into picture. And then what are the previous inputs given by the a person who is training it, or who is interacting with it, saying that whether this should be called as an alert or not. See, all of this goes into the context, and now it becomes a non-rule based system. So at some point it will ask for a prompt. Do you, like I said, that flight ticket one, where there will be a small interaction there, but it's purely based on the context. It's not like anybody setting the rule and then the system is coming out with the prompt, but it's purely based on the context. It comes out with that, right? And there you see that there is a output analyzer, then there is anomaly detection, and then we have mobile applications, email alert, or a command control center alert. So this, so the second example I'll give you is of one of the safety gear detection use case, which we generally do across multiple industries. So one of the use case there is like you have to detect a safety jacket, or helmet they are wearing, and something like that. So this is a LLM output, image encoders output of the same image, where it is saying that 2 individuals standing at a construction site. Again, this is something that we can get frame by frame analysis of it, where it says that it is they are wearing a high visibility vest, hard hats, and all of this. So now imagine this, that every new customer we onboard, we also generally retrain these models to specifically for their safety gear, for giving more accuracy on that. But with this kind of a model adding into the workflow, we may have not have to do that, and that improves the speed at which we can get a new customer, finish the POCs, finish the deployment, and then come out of it with a very high accuracy in the month one, or month first week of the deployment, right? So that's the advantage that the system is bringing for the use cases that we are working on. And again, think of it as a security person who is sitting in the control room watching 10 feet, 20 feet, 25 feet. In this model, each agent will be looking at a feed, and I can tell you that it will not miss event, which humanly we miss a lot. The rate of events that we miss at a human security level, because of the vision fatigue, that you look at the screen for a long time, and sometimes our brain generates the image for the part of it. It happens when you drive also. So like that, it's something that is in the industry, which is known, and this kind of a system can truly take care of the detecting of anomalies like a human does, right? So that's the future of video analytics that we are seeing, which will unfold, and excited to be part of that. And then that's how the agent AI agent thing concept was something that we were working on for last few months. And then when Akshita said this is what we have to speak about something, and then I thought this will be a good thing to share. And I think the last slide that I have, I think, is on the challenges and considerations. These are the 3 or 4 things that we could put together: transparency, explainability, are generally these are the parts at which it is taking some autonomous decisions, which has to be somewhere transparently. Like I said, that interaction has to happen. Do you consider this as anomaly? Do you consider or this level of threat is okay, or somebody coming at this time is okay, or is it like not okay? Probably in a, say, let's say a hostel environment, somebody coming at late at the night, probably that is okay, because students might do that, or I don't know, might not. But some kind of this transparency and this thing comes into picture, ethical considerations of all of this on the privacy. So all these are something that we'll have to work out in the future on how we can make this systems more safer and then robust to be introduced into the corporate or homes or wherever that the applications are. But yeah, I think so that's something that I had so far. I think within the time or exceeded, but yeah, so open for questions. And I believe this slide would serve in the Q&A. So yeah, thank you. I hope I was audible so far.
So
Yeah, yeah.
Akash had a question. Akash? Hello?
Yeah. Good evening, Prithvi. Am I audible?
Yes, yes. Good evening,
Yeah,
Asha.
sure.
Yes, yeah.
Sure. So I've joined here along with Rohit sir and Aida from the IHFC office. So thank you very much for your presentation. It was very interesting and accessible. We could understand several finer details of what's going on. My question is related to one of the videos which we often see at our hallway. So Pixuate trying to install a camera in a highway, and the camera is capturing data and annotating it and trying to gather information. So I just wanted to, I was curious, is this a reality or is this something like a use case which will be built upon? So just wanted
Which
to
one?
say.
This one? The initial screen that you saw, this one?
Yeah, that is one. And then you, as part of the promotion video, you also show a
Okay.
highway. Yeah.
No, we are already detecting and objects, all kinds of this thing on the highways, violation. All of this is something that we already have. The video GPT part is where the LLM adding the LLMs into the current this thing is what we are working on right now. That's the part that has started. Yeah.
Yeah. And Prithvi, I wanted to share a very, very old experience.
Sure.
This was, almost 15 years ago. I was trying to cross an intersection, and just in a rush of reaching the airport, I think I jumped the red light. And then all of a sudden, the whole intersection lighted up, and the photo of my car was taken. And then, of course, I got the bill, $140. So again, is that also happening here?
So that is so we have right now deployed in I think 3 smart cities. 2 are live and one is still in the installation part of it. But so right now that is still not because it's RLVD, what you are talking about is red light violation detection system, and we capture the number plate. Till that part, the use case is there. But I think no one has done showing that part on the screen. Maybe I think you said $40, so it may not be India, I believe. So,
Yeah.
but I think the use case wise it is there to a point, and then challan gets generated also. But showing that on the screen part is only the part that is missing, and it happens in the smart city cases, and it's a existing case. I think we have done this 3 years ago or something like that with the Ballari Smart City was our first this one. Yeah, this is there in the system, sir. Yeah.
Just wanted to end by saying a big thanks. Systems like this and technology like this is actually making people more disciplined, and so so I think thank you. Keep
Thank you
waiting.
very much.
Thanks.
Yeah.
Do we have any other questions from the audience?
Wants to ask some questions. So, Udyan sir, Ready program students want to ask some questions.
Sure.
Ashwini Yadav, any questions? Yes, Ashwini, you can go ahead.
We can't hear you, Ashwini.
Some issue with his mic. Gopal Kumar, Gopal, you want to ask any questions?
Hi, sir. Sir, I am Gopal Kumar, sir, and I'm part of this Ready cohort program, sir. Recently, I have developed machine learning model for surveillancing, sir, similar to what your general use cases is. I have developed machine learning model which will be deployed to edge device like drone or CCTV camera using Raspberry Pi or something. But the thing is, the model which we have developed required some good amount of resources in order to inference it. So like what are the techniques we can use to quantize such model to run in very low end device so that we can run in drone or some this kind of device?
Okay. So in terms of models that can run on the low power devices, currently whatever that we work on in production is on Jetson devices. Okay, so NVIDIA Jetson devices, you can achieve from Jetson Nano to Xavier NX, Orin NX, TX2. So there are variety of it which has different number of CUDA cores in each of them, and so you get a SDK to convert the models within NVIDIA, and then those models are optimized for that hardware. So ideally, what you are talking about hardware optimization is a support of the vendor who is providing the hardware to it. There is Intel, which has Intel, we know. There is NVIDIA, which has this. AMD has also another platform. So each of these manufacturers have a different platform on which they give you SDKs to convert the model and quantize the model into which works better on their platform. And we use similar techniques across. Whether you can put it on a drone depends on which model that you are running and how much power that is available for you on the drone to run this, and how long the flight time, because I believe you will have to power both the drone wings and then the this model. I've not seen people implementing this in production, to be honest, because of the the computation, the power requirement that will be there. At least all of these Jetson devices will take minimum of 20 watts, starting from nano, I think 10 to 50, 20 watts. And you have that limitation of the power on the drone. So ideal way would be to stream the data and do the processing outside for a drone. But for any other use cases where the power is not a problem, then I believe you can use it. Or there are drones where I've seen that they are flying, but they are wired to the power. So those cases also it would work. So I think that's the only limitation of power would be the case for that. Otherwise, you can easily deploy them. And I would suggest Jetson devices if you are starting, because you would probably find better SDKs and all to support your learning. Otherwise, any even Intel has a good documentation on that, but you don't get embedded boards Intel based so easily, or you'll have to figure out that part. So yeah, that's about what I have to share.
Is that Intel Open Vino, sir, you're talking about?
Yeah, Intel OpenVINO.
So like what I understood, sir, the best way is to stream the data from drone and then process is it on the ground. Is that correct, sir?
If your drone is fully battery powered, I would suggest doing that. Or if you don't need a real-time analytics, like unless you are looking at a military use case or somebody tracking or something, you can just simply record it and then do the post processing of it. So that's how I would suggest. Otherwise, if you want like a event monitoring where you are doing this thing, then a live streaming would be the ideal way to get the stream and then process locally. So it's easier to power the live streaming camera within within less than 5 watts. You'll get a streaming cameras that can generate a RTSP stream kind of a thing, and then figure out a way to access that stream. It could be powerful Wi-Fi, it could be 4G. You'll find a ways to stream that to the local device. So that's the way I would suggest over the instead of the this thing, because moment you put it on the drone, you will have to make it waterproof, this that to a certain extent, which certainly will be a challenge to begin with. Otherwise, if you consider all of these considerations, it's possible, not an impossible one. But yeah, these are the things.
Yes, thank you very much, sir.
Thank you. Hope that answered. Yeah.
Thank you. So if currently we don't have any questions from the audience, then I'll move to our felicitation part. So I would like to request Professor Saha if he's there online. I think he's there.
Yeah,
Yeah.
I'm there.
So
Hello, how are you?
Ashish, to provide the thanks to our speaker, and so this is a Springer sponsored reward voucher. Over to you, sir, for the felicitation.
So, Prathvi, I think you spoke on very interesting topic. Unfortunately, my link delayed me to join in, but I think it's a very important area, and I think Gopal has asked very interesting questions, and I think answer was also very relevant. And we hope the overall presentation was also useful. And your email is, maybe you can write the email in a chat box in case someone has more questions, they can approach you. Thank you. And from our side, we'll show you the Springer voucher, and then my team will write to you 150 euro a book you can download from the site. So please accept it. Actually, where is the voucher?
Yeah. Thank you very much, sir. And yeah, thanks.
Voucher, Udan?
Yeah, visible on the screen, sir.
Yeah.
Yeah.
Okay. I'm just trying to see myself. Where is it? Oh, yeah. So please accept it.
Thank
Videos
you
stream.
very much.
Yeah,
Thank you very much.
thank you. Yeah, I'm done with that.
Thank you, sir. And so, as sir mentioned, if anyone else is having questions, Prathvi, you can give your email ID in the chat box. They can write to
Even
you.
it.
Yeah.
Yeah, I've done that. Yeah.
And so, thank you again for such an enlightening talk and on such a cutting edge topic. So, we'll meet again next to our audience, Cobotalks audience, on next second Wednesday of November.
Okay.
So, thank you for joining in. Thank you, everyone.
Yeah.
Bye-bye.
Thank
Thank you,
Thank
team
you, everyone.
Pixuate. All the very best.
Thank you very much. Thank you.